Alright, today we are going to be solving one-step equations. This is section 2.2. Alright, so our first example is c minus 22 equals 54. And the first thing that I want you to notice is that you've got two sides of an equal sign. Okay, we've got the left side and the right side, and I've drawn a line to separate those two sides. And the purpose of this is to get our variable all by itself. So I need to get c by itself. Therefore, I need to get rid of this minus 22. So now think of whenever we were learning our properties that we have to do the inverse of this. And as you recall, it was called the additive inverse. So the inverse of minus 22 is plus 22. So I'm going to add 22 to both sides of the equal sign. Okay, and so then you could consider this minus 22. It's the same thing as negative 22. So negative 22 plus 22, remember the additive inverse says that it's going to equal 0, so we can cross those out. And then on that left side, we are left with c. And then on the right side, all we're going to do is 54 plus 22, and we get 76. And there we've got our answer. But now we are always going to check to make sure it's correct. So I'm going to take that 76 and plug it back into our equation. So this was our original equation. That was c minus 22 equals 54. So right here I have that c equals 76. So I'm going to plug that back into the c. So that gives me 76 minus 22 equals 54. And then we work that out and we see that 76 minus 22 does equal 54. And that our answer is correct. It checks out. So here would be our final answer. C equals 76. Okay, example 2. So once again, we've got two sides of our equal sign. So right there, right here is our equal sign. So here's our left side, which is 63 plus m. And then our right side has 79. So now we're trying to get this m all by itself. So I see that I've got a positive 63 over here. So the inverse of that would be a minus 63. That's what's going to take, if we subtract 63, it will give us 0. So what you do to one side, I'm going to subtract 63 to this side, I have to do on the other side in order for our equation to stay balanced. So now just like we stated, 63 minus 63, that gives us 0, so we can cross those out. And then on the left side, we are left with m. And then on the right side, we're going to do 79 minus 63, and that gives us 16. And then after we get our answer, to make sure that we are correct, we are going to check our answer. So we had m equals 16, and that's what we're going to check. So our original problem was 63 plus m equals 79. So now we're going to substitute that 16 for m. So there's one of our other properties, substitution, to see if it works out. And then 63 plus 16 does give us 79, so it checks out. And we see that this is the correct answer. All right, example 3. All right, so now we've got 2/3 q equals 1/2. And we know that 2/3, since it's being bunched up with that q, that means that it's being multiplied. And now we need to think about our properties, the multiplicative inverse. And if you remember the multiplicative inverse, we want to get that 2/3 to equal 1. So what do we need to multiply 2/3 by in order for that to equal 1? And if you remember that the multiplicative inverse says that we multiply by the reciprocal. And the reciprocal of 2/3 would mean just to flip 2/3. So that would be 3/2. And remember, what we do to one side of the equation, we have to do to the other side. So I need to multiply this side by 3/2. All right, now 3/2 times 2/3, that would give us 6/6, which equals 1. And that 1 is the coefficient that is in front of the q. Now you can put that there if you want to, but it's not necessary. And you normally would not see a 1 coefficient. So we are left with q. And then on the right side, we're just going to multiply straight across. And 1 times 3 gives us 3. And 2 times 2 gives us 4. And then after we get our answer, we will check to make sure it is correct. So we're going to do 2/3, and we're going to multiply it by 3/4, and we're going to see if it equals 1/2. Okay, the first thing I'm going to do is I see that I can cross simplify the 3's. They can both be divided by 3. And whenever we do 3 divided by 3, that gives me 1, and the same thing down there. And then I look at the 2 and the 4, and I see that both of those can be simplified by dividing by 2. So 2 divided by 2 gives me 1, and 4 divided by 2 gives me 2. And now I multiply straight across, and in the numerator we get 1, and then 1 times 2 in the denominator gives us 2. And so our answer does work out. So Q does equal 3/4. Okay, and here we've got example 4. Now for this one, we've got 3/5 times K equals 6. So once again, we're trying to get that K all by itself, and we see that it's got a 3/5 being multiplied with it. So the inverse of that would be to multiply by the reciprocal. The reciprocal of 3/5 is, remember, we just flip it, and that gives us 5/3, or 5/3. And what we do to one side, we have to do to the other side. Now we can also take that 6 and we can put turn it into a fraction by putting 1 underneath it. Now over on the left side, we've got 5/3 times 3/5, and that would give us 15/15, which gives us 1, which is the coefficient that is in front of the K. But remember, we do not need to write that 1 in front of there. It's understood that it's already there. And then on the right side, we look at that 6 and 3, look diagonally. You can only go diagonally here. So we see 6 and 3, they can both be divided by 3. So 6 divided by 3 is 2, and 3 divided by 3 gives us 1. Now we can multiply straight across, and 2 times 5 gives us 10, and then 1 times 1 gives us 1, but we don't need to put that in our denominator. So then the last thing that we do is we must check to make sure that this answer is correct. So we have 3/5 times 10, and we want to see, does that equal 6? I'm going to go ahead and change that to 10/1. And then I'm going to simplify the 10 and the 5. I can divide both of those by 5. 5 divided by 5 gives me 1, and 10 divided by 5 gives me 2. Multiply straight across, and that gives us 6, which equals 6, so it does work out, and k does equal 10. Alright, now our last example, example 5. It says if a group of 13 to 15-year-old girls surveyed, 225, or about 9/20ths, said they talk on the telephone while they watch television. About how many girls were surveyed? So, like we do in class, we need to figure out what is important here. So we see that we've got 225 or 9/20ths say that they talk on the phone while watching television. And what we want to know is how many were surveyed. Well, right here, this is also a keyword right here, of. Of the girls we surveyed, 225 or about 9/20ths talk on the phone. So 9/20ths of the girls that were surveyed, and remember of means to multiply, and we're going to use a variable for girls surveyed. Let's go ahead and use G, and that equals 225. Once again, 9/20ths of the girls surveyed were 225. So that's how we come up with the equation. So just take it piece by piece. Now we need to solve it. So here we see that they're multiplying. So in order to do the inverse of that, we need to multiply by the reciprocal. The reciprocal of 9/20ths is 20 over 9. What we do to one side, we must do to the other side. So 20 times 9 in the numerator, and then the denominator, 9 times 20 will give us 180 over 180, which gives us 1, which is the coefficient in front of the variable g. That 1 does not need to be written. And then over on this side, what you can do, I mean, you can write this out if you want to, but you can also type this into your calculator, 225 times 20, then divide by 9. I'll say that one more time, 225 times 20, and then divide by the denominator, 9. And that gives you 500. So 500 girls were surveyed. And then the last thing you would do is check your answer. We want to make sure that 9/20ths of 500 girls is equal to 225. So once again, you can do this in your calculator. You can take your whole number, 500, multiply by the numerator, so you multiply right there, and then divide by the denominator, 20. 500 times 9 divided by 20, and you do get that 225, so our answer does check out. So the amount of girls is 500.